All right, so I'm Kenny Bastani. I'm a Spring developer advocate at Pivotal. A little bit about myself. From Silicon Valley, mostly on an airplane. I travel around the world, as Andrew said, talking about Spring, spreading the good word of Spring. Also, while doing that, I wrote a book with Josh Long, my coworker at Pivotal, who's also a Spring developer advocate, called Cloud Native Java, which is all about building microservices using Spring Boot, Spring Cloud, and Cloud Foundry. I highly recommend it. Okay, so what are we going to be talking about today? We're going to be talking about reactive in Spring 5. So we'll go over what's a reactive application, so a little bit of an introduction, kind of where we came from, why we need this, why you need this, why it's important to microservices. Yeah, so why does it matter? How do you do it in Spring? So I'll show you a little demo from scratch. Using start.spring.io, we'll spin up a Spring Boot application and we'll create a reactive web front end. So what's changed? Why do we need this? What changes from the Java APIs? Some examples, and then no tech talk would be complete without a mention of microservices. So we'll look at reactive microservices. All right, so reactive applications. So what's different with reactive applications? All right, so they're fundamentally non-blocking and event-driven. So what that means is that you're going to have two models. You'll have a publisher and you'll have a subscriber. Publisher is going to send events, and a subscriber is going to subscribe to them, right? And this creates a asynchronous control flow, which means that I'm not going to have threads be blocked while I'm making a downstream request. So in microservices, for example, I have service A, call service B, call service C, D, E, right? And so what happens is that each time I make a request to a downstream microservice, I'm keeping threads open, right? So if we have a lot of communication between these applications, we're consuming a lot of resources keeping these threads open. So it's not a very efficient means of managing resources. So what's fundamentally different about reactive web applications is that they have a smaller number of threads. And the flow control changes. So if you've used Node.js or JavaScript, hopefully not, you're going to notice that it will have callbacks, right? So you have these callbacks when you make a call to a MongoDB database. You're going to also provide a callback that will be called by the producer, the publisher, when it's done getting a subset of data. And so that's the gist. Now, where we came from, so let's do a little bit of an overview of concurrency and the async APIs in Java. So here we have a basic use case, return a value, and I have a user repository, and I'm going to find a user by an ID. Right, so pretty basic. It throws an IO exception. If something goes wrong when I contact the database, I'm going to throw an IO exception. Now here's the usage. So there's my repository interface, and I'm going to have an instance of it. I will call that find by ID, and it returns back a user. And I have to try catch. I have to catch the IO exception if something happens. Now with a future, what changes is we don't need to throw a IO exception because that is likely going to happen in another thread, so we won't be able to catch it. And we're just going to add in their future, and then we're going to provide the user object. Now I'm going to call back to that repository, user repository.find by ID, and I'm going to assign that to a future variable, which wraps a user object. And now I'll call future.get. That's going to block, and then when it's finished, it's going to return back that user. Now, the UG here is that it's very ugly having to try catch all these exceptions. So if you have a microservice and you're making a lot of HTTP calls using REST template with Spring Boot, you might notice that you have a ton of try catch statements. It just becomes kind of ugly and inconvenient to read that all the time. It becomes inconvenient to try catch all the time. So it's not really, I guess, the best syntactic sugar. So here we're going to return a value with completable future. It's a bit different. This is in the Java 8 Streams API. So here we have repository.find by ID. We'll assign that to a future, which is completable future. And here that's where we're going to provide a callback, right? So in like JavaScript with a callback, we're going to call future.whenComplete, and we're going to provide here a Lambda expression with user and throwable. So user is then going to be provided into that method, and we're going to be able to subscribe to when that event comes in, and then we'll be able to get that user. And here we're going to return a collection. So I have my user repository, I have my completable future, and then inside that I have my collection, my list of user, and this is a find all method. So I'm going to get all users in the database. And then I have my void, which is going to allow me to, I'm not going to get anything back, but I'm going to subscribe to when it's complete or if an error is thrown. And so there's three fundamental things here, right? We have a single item, we have a collection, and we have a void. So with Completable Future, what's good about it is that it's fundamentally the right idea for use in async APIs, right? So that contract is actually quite good, and so we want to use that. But there's some deficiencies there we'll go over. So it also allows declarative composition of async logic, and it keeps these Lambda expressions readable, right? So we have much more readable code. The problem is it's not ideal for collection return values, or is it good for latency-sensitive data sets? So if I have a ton of items in my collection and I'm returning that all, I have to read that entire collection. I can't get them one by one, which is much more efficient. So it's not very good for large infinite data sets, and by not good, it won't work because you'll never get back that infinite data set, so we can't do it. So what if we return a stream? So in Java 8, we have the streams API. And so let's look at what that might look like. So here I have a flow of data. And let's say that I have an onNext method, right? So I'm subscribing to a result, and I'm calling onNext. I'm providing some function, some callback, and I'm going to consume that data, right? So I'll have .onNext, 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 and then onError or onComplete. So I can't really subscribe to an error and then continue in this model, and that's something that we can do with reactive streams. So a couple use cases here. I guess I should go through all these. So the success use case here, I'm going to use the onComplete notification, right? So we can kind of think about this as notifications. If anyone's a front-end developer in the room, I started out as a front-end developer. And so if you're familiar with jQuery and JavaScript and event handling, it actually is quite similar to what we're doing here, right? So our notifications are just going to be subscribers to these events. So for success, I'm going to say onComplete. For error, I'm going to say onError. I'm going to get that throwable exception, and I'll be able to respond to it. For match, I'm going to use onNext and then onComplete. For no match, I'll also use onComplete. For a failure, I'll use onError. For that, sorry, we're going void to item. So for user items, match, no match, and failure. And then finally for collections, we have two matches here. We'll call onNext, we'll get the user, onNext, and then onComplete. For no match, then just onComplete, and then failure, onError. Pretty simple. But we're going to keep going back to this pattern here, which is void, item, collection. So for the Java 8 stream, things have gotten a lot better. And in Spring 5, we have support underneath the hood. We finally support Java 8, and so our engineers in Spring can actually use Java 8 streams. We haven't been able to do that until now. They're very excited about it. So it's a great example of the kind of APIs we'd like. Again, right? We think it's a good contract. It's a good model. Also, it's a declarative composition of async logic per item, meaning that we can stream results per item and get them back and then respond to them. And then again, lambdas keep things readable. But it's built for collections, and it's not active or a hot source of data. So what that means is that if we have a microservice or a client and then a microservice, right, it's a remote server, and we call that with the Streams API, we can't get individual items from that HTTP connection, right? So it's not a hot source of data. And it's not very good for latency-sensitive data sequences because if we return a collection, we have to return everything. Okay, so the good stuff, reactive streams. So this is the new stuff. This is the stuff that you're going to be able to use in Spring 5. You can use it today with Project Reactor, which is another project that we have. But what's Reactive Spring is really it brings in Project Reactor into the Spring Framework internals and allows you to use Flux and Mono, which is an item in a collection. All right, so metaphor time. All right, so we're in Atlanta. People in Atlanta like baseball, I think. I'm pretty sure. I liked baseball when I was here. I was a Braves fan. Still am, although I'm kind of a Giants fan now. But here we have an example of a batting cage. Who goes to batting cages? Just curious. Anyone? Great metaphor. All right. Good job, Kenny. All right, so here we have a reactive example. I have a publisher, which is my pitcher, who's going to be throwing a stream of balls. And then I have my batter, who's going to hit those balls, right? So each one of these baseballs is an event, right? And so typically there's going to be some time in between each one. The batter has to be ready before the pitcher throws the ball, right? So this is an example of a publisher who's going to publish to a subscriber, and this subscriber is going to respond to that event and hit the ball out of the park. Now that's reactive. Now what's not reactive is what most people are doing today, which is this, right? So my subscriber is just going to sit there, and it doesn't matter whether or not they're ready. The balls are going to come anyways, right? So if you want to think about calling any HTTP server without reactive support is kind of like the server's not smart about how it's sending things. It's just going to send a constant stream of baseballs, and your client's just going to have to be able to handle that, right? So reactive streams allows the publisher-subscriber model to communicate bidirectionally. So if I'm a subscriber, I can let that publisher know when I'm ready for more items, right? And I can do that remotely. I can do that across the network, which is really powerful. And so we have some interfaces here for that. Our publisher has a subscribe method, which provides a lambda, which is going to be a subscriber. And then our subscriber interface, which is going to be of a type, has on subscribe, on next, on error, on complete. We saw that earlier. And there's this idea here about back pressure. So back pressure is interesting, right? Because what it means is that as a subscriber, I can tell the publisher how I want to receive my data. So if I want to receive it all at once, I can certainly do that. I don't want to do that. I can receive them one by one, or I can say I'm going to receive them in a subset. So maybe every 2 items, I'll download them, I'll perform an action, say I'm ready for more, and I can define that from the subscriber side. So Project Reactor has been around for a little bit. It's based on RxJava, and it's a reactive streams library for the JVM. Who's using Project Reactor today? Just curious. This is really cool stuff. So one guy. Good. So this is really, really cool stuff. And it says a lot that the Spring team is going to include this into the Spring framework because there's a lot that needs to be overhauled for that, right? You have 2 different models. You have one that we've always been using, right? And that's the non-reactive. And then we have side by side in parallel all of the reactive libraries. And so this is a huge undertaking with Spring 5. And so we're very excited about it, and we want to provide that support. So with Project Reactor, it's going to provide you declarative operations on items. That's very similar to the Java 8 stream. So if you use Java 8 streams today, Project Reactor is going to provide you a very similar experience to that. So going back to the idea of void item collection, the types that we're going to use for this, a flux is going to be a collection, and a mono is going to be a single item. So in a mono, which is 0 or 1, this is a diagram here that explains how that works. It's very boring, but I'm going to walk through it. So I'm going to have my operator here. That's going to perform a data transformation, right? So I have my publisher on top. That's going to publish that single 0 or 1 items, and that's going to go to the operator, and the operator is going to make a transformation, and then it's going to send it along to the subscriber. Now we can have a chain of these operators, right, with Java streams, which means that I can have one operator that's maybe a filter, and that's going to constrain a subset, and then maybe I have a mapper, which is going to turn that into a different item. And then if something happens along the way, we are going to, at the very bottom, that arrow represents time. We will just replace that with an X, meaning that it terminates that stream. Now, for a flux, a collection, we're just going to be streaming a set of items, one by one. So here I have 1. That's going to go to the operator. And asynchronously there at the bottom, our subscriber is going to subscribe to each one of these items. That's coming through that pipe, being transformed, and then it's going to do something. But the idea here is that I don't have to wait for each operator to complete on the entire collection. It's going to be one by one. So I'll have one operator who's going to send along to the next operator, and this is all happening asynchronously. We also have reactive repository support, so we can actually stream things from a database. That's very exciting. With MongoDB, we have reactive support. They support a reactive driver, which means that if I make a query to MongoDB, I don't have to wait for everything to return. I can use reactive streams as a subscriber to say I'm ready for more data, and MongoDB will send it along. So here in this example, I have a basic user repository, which is I have a mono user, flux user, and mono void. So I have that item collection and void. Now how we're going to use this is I have a repository.findAll. You're pretty familiar with that. And that's not actually going to get all of those items, right? It's going to say, this is what my pipeline looks like. I'm going to set up a subscriber model. I'm then going to apply an operation asynchronously to each item in this stream. And they're just going to flow through these operators, right? So I start with filter. I'm going to filter a subset of users. And then I'm going to map that. And then I'm going to log it out. And then to actually kick this off, we have to use the subscribe method. And the subscribe method is going to start this chain, right? So until we call subscribe, it's not going to do anything. It's really just a definition. So the subscriber triggers the flow of data, and then one by one, they will filter and trickle down all the way to the log. So by default, we consume without back pressure, which just means we're just going to get them one by one. But what back pressure means is that we can tune this dial up and down. We can adjust the volume to set the capacity, which means here's my buffer size. I'm going to add a use capacity operator, which means that I'm going to apply each operator to 2 items, return that, so the subscriber will get those 2 items and then go on to the next 2. So I can dial that up and down. So here I have on subscribe. I'm going to request 2, on next Jason, on next Jay, and then I'll request another 2, and then Joe and John. So with Spring Data projects, so we have a bunch of Spring Data projects. Who's using Spring Data today? Great. So we have a few projects in there that have reactive support today. They're not GA yet, but we have Mongo, we have Redis, I believe Cassandra, there's a few others. But what that looks like here is the only thing that's really changed is, again, we have mono and flux to return items in collection. And then we're just appending reactive onto everything. So if you're familiar with Spring Data, we have this beautiful abstraction model, which at the very bottom we have the base repository, and then all of the different databases have their specific traits, and so we have these abstractions that pile on top of it. So if I'm using Spring Data JPA, I'm going to get relational database specific traits. If I'm using MongoDB, I'm going to get document database traits. So here we have the abstraction CRUD repository. We're just adding on reactive CRUD repository, and so each one of the vendors, the database projects, can then implement that. And so again, what changes here, I'm just going to find by first name and last name. I want to find one person, I'll return back a mono person. If I want to return back a collection, I'll use flux person. Now what that looks like is in the framework is we have end-to-end back pressure, right? So from the HTTP server to the web framework to the controller to the repository, end-to-end means that we're going to be able to stream from the database all the way to the front end. So as you're in the front end, you're actually going to be seeing one by one this stream of data coming in directly from the database, right? So this chain, it's not going to hold these blocking threads. It's going to stream them all the way to the front end. So it's very, very efficient. We also have reactive web support. So again, if you want to have a web MVC controller that streams data from a repository, you can certainly do that. And I'll show you an example of that. But what that looks like here is now in Spring 5, you'll be able to return back a mono or a flux, and you just get it out of the box, right? So if you return back a mono and your repository supports reactive streams, it's just going to stream that to your client. Now here's this is why we think it's so important, why Jürgen and the Spring team thinks it's so important, is that this is the biggest overhaul in a very long time to Spring Framework. And so what we're seeing here is we have side-by-side components, right? So we had Spring Web MVC, and side-by-side we're going to support, which is now called Spring Web Flux, which is the reactive version of Spring Web MVC, right? So we'll be able to use both of those. Now they're going to share a set of libraries, but they are 2 separate implementations. So we have our servlet API for Web MVC, and then for WebFlux, we have now reactive HTTP, which is going to sit on top of our reactive application server, which is either Netty Undertow, Servlet 3.1. But for the servlet API for Spring Web MVC, we have just our basic servlet container. So again, it's parallel to Spring Web MVC, so you can use your REST controllers with reactive streams in Spring 5, and then it operates on reactive HTTP requests and responses. So if you have that chain of microservices now, you're not going to have to wait for each microservice to return a response and collapse the call chain. You can stream all the way to the front end. Even if you're going 5 deep, it's going to stream results all the way back. It's really cool. So here's an example of a non-blocking HTTP GET, which means that we're just going to return a result. We're not going to block the thread. So how you would do it with Web MVC, here I have a GET user method, and I'm just going to return a new user. I'm not going to call to anything and block. And now in the bottom here, I have the reactive version of that, which is going to return back a mono user. And it's going to call a reactive repository, and then we get an async non-blocking method. Now the reverse of that, you can also post. So I can post so I can actually publish on post, which is pretty cool. So if I'm calling a downstream microservice and I'm adding a set of accounts to a collection, I can stream those to that server, and it's going to subscribe to those, right? So we have this model all across the board. Now this is probably the coolest thing I think that most people will get a kick out of, is that we have native support for server sent events. Now what that means is if you're a front-end developer, what you can do is you can call a Spring Boot application and you can stream to your browser results on demand. So you can see an entirely different experience rather than trying to pull things. You can keep a connection open and items will flow into the browser and you can see updates. And so we're going to take a look at that in a little bit. And then finally, we have our web client. So if we're making calls from service to service on the back end, typically you use a REST template. I think we're going to have REST template support that wraps a reactive web client, but this is how it works. So you have your web client, you'll perform, in this case, I think we're making a post, describe your content type, and then extract the response. All right, so let's do a demo. So I'm going to fire up start.spring.io. And we're going to create a reactive web application. So the first thing you'll need to do is I'm going to generate a Maven project with Java. I'm going to use Spring Boot version 2.0 M2. So that has this Spring 5 in it. So Spring Boot 2 is in milestone 2. And so if I go to my dependencies here, I can choose web, reactive web, instead of regular web. And I'm going to name this Reactive Spring. And I'll go ahead and generate my project. Now, I've loaded this up in my IDE already to make things smooth. But here we have a basic Spring Boot application. I added one comment here just to remind myself what I'm doing. And so what we're going to do here is we're going to create a REST controller with Spring Web Flux, which is the reactive version of Spring MVC, and we're going to stream some server sent events to a client. And so the first thing I'm going to do here is I'm going to create my class reactive controller, and I'm going to annotate it with REST controller. And then I'm going to create a method in here, public. We're going to return back a set, so we'll use flux. I'm going to stream a set of messages. So that'll be a flux of a string, so a collection of string items. And we'll say string flux. All right, so I'm going to provide a request parameter. And I'm going to call that what? Actually, let's call this echo, because it's kind of like an echo. And what do I want to echo? Now I'm going to return back here. So this is where that stream API comes in. I'm going to call flux, and I'm going to generate a new flux. Actually, I think I'm going to use interval. So interval, I can create a stream. This is really good for demos. Or if you want to maybe make a call every so often at some fixed interval, I can go here and specify the duration I'm going to say, let's do milliseconds. Let's do every second would be 1,000. All right, so now I have a publisher that every second it's going to publish to a subscriber. So the next thing I'm going to do here is I'm going to transform that. So I'll use map. And I'm just going to return back my what. And let's go ahead and add in here the long. I think that'll be the millisecond. Okay, so that's it. So now I'm returning back a flux, which is my stream, which is continuous. So it's going to continuously publish forever, indefinitely, a stream of strings. And what I need to do here on top is I need to add in, just like we would before, I'm going to add in a get mapping. I'm going to say path, put that at the root. And then I'm going to say that I want to send a server sent event. And so I'll say produces a text stream, media type. And that'll be text event stream. Right, so that type here, if you go and see, it's just text / event stream. And that tells the browser that it's going to keep that connection open and stream results. All right, so we're all set to spin this up. So I'm going to go to my terminal here. Let's make that bigger. So Maven Spring Boot run, that's how I'm going to start the application. It's going to start up on port 8080. And we're up and running. All right, so now if I went from the browser, it'll probably just hang because it's a stream, and I usually, if you're consuming a stream, you would want to use something like server sent event, an event source in JavaScript, and so you can actually have an asynchronous callback that will subscribe to items being published by the server. I'm going to show you that in a little bit, but I'll just show you from the command line how that works. So I can actually just make a curl request, which is an HTTP GET, and I'm just going to go to my local host 8080, the root endpoint. I do have to provide my what, and that'll be hello. And yeah, and so there we go, right? So it's keeping that stream open, and that server is just continuing to publish data, right? And so I can have this layered on top of layer with my web servers and a microservice architecture. Service A calls service B and C, and it's just going to stream those all the way to the front end. I think that's pretty cool. So I think it's really going to change the way that we experience the web, right? So Spring Boot is one of the most popular, if not the most popular framework for Java today. So just think about how that's going to change the user experience for everybody in the world. I think it's pretty exciting. All right, so Reactive Microservices. Taking this to the next level, I'm going to show you a sample application, which is, well, I guess we're going to go over microservices first. Who's heard of microservices? Yes, all right. So just a quick review here. This is a microservice architecture of an online store that I put together for the Cloud Native Java book. And this is a full sample application. So I'm not an ivory tower architect. I didn't just draw this. I drew it and then built it and modified it. At the very top, I have my web front end. That's my online store web. That has my static JavaScript, HTML. And then I have my edge service there, which is my API gateway. Which is a Spring Boot application. I'm going to call that, and that's going to expose me to all these back-end microservices. So if I go to / catalog, it's going to route me to catalog, return back a response, right? So at the very minimum, what we have here without reactive is we have a call chain, which is too deep. So I will call from online store web to the edge service. I'll keep that connection open, those threads open. They'll block every time I make a downstream call. Now with reactive support, I'm going to just subscribe to events on the front end, and it doesn't matter how far I go. It's going to publish items one by one, and I can subscribe to them from the front end. So now I'm going to show you an example application of this, of a microservice architecture, a new one that I put together, which is called Spring Cloud To-Dos. It's much simpler. I realized 10 microservices on a laptop was kind of expensive resource-wise for most people, so I simplified things. And so let's go over the architecture here. I call this a service block architecture. which combines microservices with serverless functions. So with Spring Cloud Function, another new project that we just booted up, we can create serverless Java functions using Spring Boot. And so in this architecture here, I have a core service. That's my microservice. And it's able to publish events to serverless functions. That's going to write to a reactive MongoDB database. And then I can subscribe to those from that core. And I can see my Lambda functions actually publishing events live, which is pretty cool. Also, I have tasks here, so to keep things durable every time an event gets created, I'm going to store that in my RabbitMQ message broker. That way, I'm not going to lose any events. And then I have my MySQL database in the back end. All right, so I'm going to fire this up. If you're interested in cloning it, it's at, I think I have a slide here. It's on GitHub, and I used to use Docker because it made it easy to fire all these things up, and then Dave Sire told me, like, that's totally useless. You're putting a container inside of a container just to run containers. So I got better at Bash and created a bootstrapper. So this is the project, and it has a config server, discovery service, it has a core service, and then functions. And I'm going to fire all of those up all at once. I have to make sure I bring that down. Okay. So now it's just building, and then one by one, it's going to start up these JVM applications. So first, it's going to start up the, so I'm running, instead of on AWS Lambda, I'm going to run my metrics function locally. The metrics function is responsible for collecting actuator metrics from all instances of a Spring Boot application. So if you're familiar with actuator, we got a demo of it earlier. It's going to allow me to pull and get metrics from my instances, and then I can put them in something like Prometheus, and then I can create a visualization in Grafana. And so the problem there is that if you have a highly available system, you have to pull each one of those instances. And so I created a function that's just going to collect them from all of the instances, and it's going to aggregate those, and I'm going to see a reactive actuator dashboard, which we can actually see those actuator metrics updating live. So I think we're just about ready. All right. Yep, so Eureka is online. Let's go and see if everything is up, and it is. So this is my Eureka dashboard, which is Spring Cloud Discovery Service. And this is how I'm going to be able to find other services in my cluster. And so I have my core application. That's going to be my backend API. And then I have my static content in my user interface, and that'll be my front end. So I have a front end container and a backend container, which is called a backend for front end, or a BFF. And then my to-do core is going to be able to call the metrics function to aggregate those metrics. And so if I go to my UI here, which is going to bring up an error, but if I go to the root endpoint, I get my AngularJS application. And now I can start creating tasks so I can remember what to do. But before I do that, let's go ahead and pull up another browser window, which is going to be my actuator metrics. I'll pull that here. And because I'm using Zool, I can actually proxy to the backend, that backend service from the front end using /API. And that's going to proxy to whatever is in that core application. And so the dashboard that I created for this is called aggregator.html. And so I'll pull that up. Should be, yeah. So we see some metrics that have been reported. And now I'm going to create a few items. So let's see. I like grocery store, eggs, bread, expense reports, travel, slides. All right, so as I add these items, each time I do that, it's going to publish a new event to that backend. So we should be able to see this update. Let's try this again. Let's go localhost 8080. I screwed something up. This stuff always works when you're by yourself. It never works when you're up on stage. Never. Let's see, what do we got here? Connection refused to Rabbit. I must have shut it down. Oh, I started up on a different network. Success. That looks good, maybe. I think maybe it worked. Yay. All right. So let's try that again. All right, so now we should be able to see these events get published to the back end. It should update that user interface. So eggs, bread, expense reports, and yeah, you can see them changing, right? Yeah, so if you look at that one here, all right, so I have another dashboard which is more compelling. So I'm going to go to gauges, which is a work in progress, which has some gauges, and we should be able to see them throttle. So if I do things, one of those gauges should hit. Oh, there it goes. Super exciting, right? All right, so that's about it. It's going to change the web. It's going to change the web. All right, so I think we're just about out of time. So I'm actually going to open it up for questions. Any questions? Cool, well, I'll be around today and tomorrow. Oh, there's one. Yes, I can provide them to you. I'll give them to Andrew or Tosh, and they'll send them out to everyone. Yeah, question in the back? You don't have to. So if you don't support reactive maybe on your front-end container, then it's just going to get all of those items and then return them. But yeah, you would probably want to have that entire stack support reactive so you can stream things all the way to the front end. Now you can be declarative whether or not you want to block or if you want to stream. And so that's important for some things, right? You want to make sure that you have an atomic transaction, then you'll want to make sure that you don't stream. Question? So you have an in-flight transaction and it goes down, you'll get an error published. So basically what happens on the client side is you'll get an error notification, which will be a timeout or not available, basically a 500. No, it won't return a 500, it just won't return anything. But you'll get an error and that will stop the subscription and you'll handle that error. Yeah. Yeah, so you can use a retry template, and the retry, you can use exponential backoff. You can use circuit breakers. Circuit breakers with Spring Cloud are going to allow you to check whether or not a service is healthy. And so if it gets a velocity of errors, it's going to flip a switch, go to a backup, and then when that service comes back online, it'll call back to that service and get the response. Any other questions? Yes. Sorry, say it again? A cluster. Well, so actually, let's consider this a cluster, right? So we have many different applications and then many different instances of each application. Now, if they're all speaking reactive Spring and they're using reactive streams, then we're going to get much better latency in our requests, right? Just as a product of there's no blocking. If I have these large call chains, I have to wait until the furthest one completes before it returns back upstream. So we end up having to wait for each one of these requests to complete. With streams, we don't have to. We open that stream up and it's like a river and it flows all the way back to the original requester. So you're going to get much better latency. Did I answer your question? Well, okay, we'll talk about it. All right, so I'm going to go ahead and say thank you very much, guys. I appreciate your time. I'll be around for questions. Thank you.